The Nosredi Special Transport to Poncevo was one of those operations where everything aligned: planning, precision, and perseverance. On the final Monday of November, an 11-vehicle convoy rolled out from the Andrzejewicz Strojerny manufacturing plant, beginning a long and carefully coordinated journey toward the port of Bratislava. The mission marked the start of a complex transport assignment, delivering oversized chemical equipment destined for the Azotara Pančevo industrial facility in Serbia. At the heart of the convoy were two massive chemical columns, the largest and most demanding components of the shipment. Once loaded onto specialized Goldhofer THP modular trailers with turntables, these units formed truly imposing combinations. One measured 55 meters long, 4.1 meters wide, and 5.1 meters high, with a total weight of 156 tons. The second followed closely behind at 53 meters in length, 4 meters in width, 4.5 meters in height, and a weight of 120 tons. Moving cargo of this scale leaves no room for improvisation. Every kilometer must be engineered in advance. Power came from heavy-duty tractor units, including Mercedes-Benz Arocs and Actros models, supported by man-prime movers, all selected for their torque, braking capacity, and reliability under extreme loads. Surrounding them was a full technical escort, pilot vehicles, route support teams, and crews responsible for on-the-fly adjustments to infrastructure, traffic control, and safety management. This was not simply transport. It was a mobile construction project advancing meter by meter. The defining challenge of the journey awaited in the mountains. Beneath the Czerweno-Horskie Sedlo, here, a series of tight serpentine bends tested both machines and drivers to their limits. Negotiating these curves with loads stretching over 50 meters required absolute precision, synchronized steering on multi-axle trailers, and constant communication across the convoy. Progress was slow, deliberate, and tense, as each bend demanded careful alignment to avoid barriers, slopes, and gradients that left no margin for error. Despite the difficulty, the convoy pushed through, proving once again what meticulous preparation and experienced crews can achieve. Operations like this highlight the unseen expertise behind industrial logistics, where success is measured not in speed, but in safe arrival. More details and behind-the-scenes insights are available through Nosredi's social media channels, and a full video presentation, including striking drone footage of the mountain ascent, will be released soon. Moving an oversized load is never just about miles. It is about geometry, timing, and absolute coordination. This Perkins transport assignment was a textbook example of how turning challenges define heavy haul operations. The cargo rode on a 150-ton Perkins perimeter frame trailer with a 70-foot well, forming a combination with staggering dimensions. An overall length of 248 feet 4 inches, a width of 16 feet 4 inches, a height of 16 feet 7 inches, and a gross vehicle weight of 499,000 pounds. On paper, the route was 117 miles. In reality, it was a series of carefully engineered maneuvers. The journey included 20 critical turns, each one surveyed, modeled, and rehearsed long before the wheels ever rolled. With a load this long, turning is not a simple steering input. It is a slow, deliberate choreography between tractor, trailer, and crew. Axle steering angles, swing clearance, and off-tracking had to be managed inch by inch, especially through tight intersections where roadside obstacles left no margin for error. Behind the scenes, execution depended on people as much as equipment. A 5-person Perkins crew worked in lockstep with 2 Minnesota State Patrol units, maintaining continuous, clear communication. Every command, stop, and adjustment was confirmed before action, ensuring consistency and safety throughout the move. By the time the convoy reached its destination, the numbers told only part of the story. What truly defined the run was discipline, preparation, and communication without a single breakdown. In oversized hauling, success is not measured by speed. It is measured by how smoothly every challenge is turned into a controlled solution. Gantry crane transport plays a critical role in the modern movement, handling, and storage of oversized and high-value industrial equipment. In sectors such as renewable energy, power generation, and heavy manufacturing, these systems provide the precision and load control required to move components that are simply beyond the limits of conventional cranes or forklifts. At the heart of gantry crane transport is versatility. Large wind turbine components, including tower sections, nacelles, and blades, can be lifted, translated, and positioned with millimeter-level accuracy. The same applies to massive transformers, boilers, steam turbines, generators, and gas turbines, where weight often reaches hundreds of tons and tolerances are extremely tight. Gantry cranes distribute loads evenly through multiple lifting points, reducing stress on both the equipment and the supporting ground or foundation. The transport process typically begins with synchronized lifting. Using hydraulic or electric hoists, the gantry system raises the load vertically, keeping it perfectly level to protect internal structures and alignment surfaces. Once clear of supports, the load can be moved horizontally along rails or self-propelled gantry units, allowing controlled transport across assembly yards, storage areas, or production halls. This capability is especially valuable in confined spaces where traditional mobile cranes lack maneuverability. Storage operations benefit just as much from gantry crane systems. Heavy components destined for future installation, such as hydroelectric dam equipment or photovoltaic infrastructure modules, can be safely placed on prepared foundations or storage frames. The controlled motion minimizes vibration and shock, preserving mechanical integrity and reducing the risk of costly damage. Safety is a defining advantage of gantry crane transport. Redundant lifting systems, real-time load monitoring, and precise control interfaces allow operators to manage extreme weights with confidence. Weather conditions, ground-bearing capacity, and load dynamics are carefully evaluated before each operation, ensuring predictable and repeatable results even in challenging environments. In an era defined by large-scale energy projects and increasingly complex industrial systems, gantry crane transport has become indispensable. It bridges the gap between manufacturing, logistics, and installation, enabling the efficient handling of the world's heaviest and most valuable equipment. More than just a lifting solution, it is a cornerstone technology that keeps global energy and infrastructure projects moving forward safely, reliably, and on schedule. This operation captures a 520-ton slurry hopper being transported from Kazakhstan to Uzbekistan for a natural gas processing station, using a 3-line turntable heavy transport system. Designed to handle extreme loads, the modular trailer configuration allows controlled rotation and precise steering through tight corridors and uneven terrain. Every movement is calculated, from axle load distribution to turning geometry, ensuring structural stability over long distances. The convoy reflects the scale and discipline of Central Asian energy infrastructure logistics, where engineering accuracy and coordinated execution are essential to move oversized industrial equipment safely across borders. On November 4, 2015, the quiet roads of Aubigny-sur-Ner were transformed by an extraordinary logistical operation, a Butagaz exceptional convoy transporting massive industrial tanks to the local plant. Each vessel weighed 350 tons and required meticulous planning to move safely. The cargo was delivered using 3 specialized transport combinations, each stretching 64 meters in length, 5 meters in width, and nearly 7 meters in height. Progress was slow and deliberate, with escort vehicles, route modifications, and precise coordination at every intersection. This convoy highlighted the complexity of heavy transport engineering, where road infrastructure, vehicle capability, and human expertise must align perfectly to deliver oversized loads without error. This is a quiet but highly sophisticated operation deep inside a wind farm in Lower Austria. Felbermayr is relocating the crawler assembly of a Liebherr LR11000, one of the largest crawler cranes in the world, using SPMT technology. Instead of dismantling the undercarriage, the entire crawler unit is lifted and carried as a single load. Every movement is slow, deliberate, and precisely calculated. The self-propelled modular transporter steers with millimeter accuracy, threading its way between towering wind turbines without disturbing the terrain. Ground pressure, stability, and alignment are constantly monitored. It is a powerful reminder that modern heavy transport is not about speed, but about control, where engineering discipline and flawless execution keep massive machines moving safely through tight, sensitive environments. Watching a KRAZ 255B1 ford a river is a reminder of what true military-grade engineering looks like. This legendary Soviet 6x6 truck enters the water without hesitation, its massive tires cutting through the current while the chassis remains steady. With high ground clearance, sealed driveline components, and relentless torque, the KRAZ moves forward where modern trucks would stop. Water rises around the axles, but momentum and traction are never lost. This is not a stunt or a test. It is a demonstration of purpose-built design. Some machines are made for roads. The KRAZ is made for whatever lies beyond them. A routine winter journey turns into a long standstill on a county road south of Oslo. A Latvian Prisma tractor-trailer slides into a roadside ditch, trapped by snow, ice, and the narrow profile of Road 156. With the vehicle blocking traffic, police step in and requisition a heavy rescue unit to reopen the route. On January 15, 2015, a Falk recovery hauler arrives, carefully rigging the stranded truck for extraction. After hours of controlled pulling and precise positioning, the tractor is finally freed. Nearly 3 hours later, Norwegian truckers waiting in line are cleared to pass, restoring traffic flow and proving once again how demanding winter roads can be. This moment is a sharp reminder that earth moving is as much about skill as it is about horsepower. A Cat 637 e-scraper slips off the edge of a stockpile, its massive weight shifting suddenly as gravity takes control. For a brief second, the situation looks lost. Then experience takes over. The operator reacts instantly, adjusting throttle, steering, and articulation with calm precision. Instead of panicking, he uses the machine's balance and drivetrain to regain control. Slowly, deliberately, the scraper settles back onto stable ground. It is not luck that saves the day. It is judgment earned over years of seat time. In heavy equipment, true mastery often shows itself in moments when everything goes wrong. On the Kolyma Winter Road, a Volvo FMX pushes forward across one of the most unforgiving routes on Earth. Here, the road is not asphalt but frozen ground, snow and ice hardened by extreme cold. At times, the truck must cross improvised ice runways, where precision and trust in the surface are critical. Speed is controlled, steering inputs are smooth, and every vibration is carefully felt through the chassis. One mistake can mean breaking ice or losing control in isolation. This journey is a testament to winter logistics, where discipline, experience, and machine reliability decide whether the road allows passage. The KAMAZ 55111 is a rugged Russian dump truck built for hard work. Known for its durability and simple mechanics, it thrives on rough roads, construction sites, and challenging off-road conditions. The recovery of the John Deere 9520 turned into a real-world demonstration of how quickly a routine operation can escalate when weight, terrain, and improvised equipment collide. The massive articulated tractor became immobilized after getting hung up against an oversized spare tire, which acted like an unexpected anchor beneath the chassis. With its immense weight and limited traction in the uneven ground, the 9520 could not free itself, no matter how much torque was available at the wheels. What initially looked like a simple obstruction soon proved to be a serious recovery challenge. The large spare tire prevented proper articulation and robbed the tractor of the leverage it needed to climb out. Continued attempts to drive only increased the risk of driveline strain and tire damage, making it clear that outside assistance was the only safe option. That assistance arrived in the form of a DAC heavy recovery truck, purpose-built for extreme situations like this. The crew approached the scene methodically, first stabilizing the tractor and assessing load points to avoid stressing the frame or articulation joint. Heavy-duty winch lines were rigged with precision, ensuring controlled force rather than brute pulling power. As the DAC applied steady tension, the John Deere slowly began to shift. The oversized spare tire was freed from its binding position, and the tractor's weight redistributed back onto its wheels. Within minutes, what had been a stubborn, motionless machine was rolling again under its own power. The incident was a reminder that even the most powerful agricultural equipment has its limits. In environments where mass and terrain work against you, success depends not on horsepower alone, but on proper recovery strategy, specialized equipment, and experienced hands that know exactly how to bring heavy iron back into motion safely. As the tractor-trailer attempts to cross a muddy stretch of uneven ground, traction quickly disappears. The soft soil and rutted terrain cause the rig to lose balance, tipping the tractor and trailer onto their side. With the load immobilized, a second heavy tractor arrives on scene, securing a tow cable to the disabled vehicle. Using controlled power and careful positioning, it slowly pulls the overturned rig back upright, restoring stability and preventing further damage. Trucks Adventure Brazil 6 captures the raw reality of heavy trucks operating deep inside the Amazon, where roads are temporary and nature dictates every decision. This is not a staged expedition. It is a real encounter with heat, humidity, mud, and isolation, where even the strongest machines are tested daily. The routes cut through dense rainforest, crossing rivers, clay tracks, and deeply rutted sections that dissolve into mud after every rainstorm. Tires struggle for grip, engines work under constant load, and drivers must read the terrain ahead with absolute focus. In the Amazon, momentum is everything. Lose it in the wrong place, and recovery can take hours or days. What makes this adventure remarkable is the teamwork. Drivers rely on each other for guidance, recovery, and route selection. Winches, tow straps, and shovels are not emergency tools here. They are part of normal progress. Every successful climb or river crossing is a shared victory, earned through patience and coordination. Beyond the machines, the environment itself commands respect. Heat pushes cooling systems to their limits, while water and mud threaten mechanical components at every turn. Yet the trucks keep moving, proving that preparation and experience matter more than brute force. Trucks Adventure Brazil 6 is not about speed or spectacle. It is about endurance, adaptability, and the relentless challenge of moving heavy vehicles through one of the most demanding landscapes on the planet. On the remote Colniza MT road, the line between progress and disaster is painfully thin. What should be a highway is little more than a muddy corridor carved through the forest, softened by rain and punished by heavy traffic. In this moment, an Iveco heavy truck advances slowly past a Volvo FH already lying on its side, a silent reminder of how unforgiving this route can be. The ground is saturated, ruts are deep, and the road edge offers no support. As the Iveco moves forward, gravity begins to take control. The truck leans, suspension compressed on one side, tires sliding toward the same ditch that claimed the FH. For a few tense seconds, it looks as though history is about to repeat itself. The driver's response is calm and deliberate. No sudden throttle, no sharp steering corrections. Instead, controlled inputs, steady momentum, and absolute focus. The engine works at low speed, delivering torque without breaking traction. Every vibration through the chassis tells a story about the surface beneath the wheels. This is everyday reality on many interior Brazilian routes. When weather turns bad, even experienced drivers are tested to their limits. Recovery services are far away, and a single overturned truck can block the road for hours or days. The Iveco eventually clears the danger zone, still upright, still moving. It is not a victory celebrated with speed or noise, but one earned through restraint, experience, and respect for a road that never forgives mistakes. What begins as a routine agricultural recovery quickly turns into a tense test of coordination and experience. A mobile crane heavily loaded and operating on soft ground has become bogged down in deep mud, its wheels sinking unevenly as gravity pulls it toward a nearby ditch. With every minute that passes, the risk of a rollover increases. Enter two farm tractors, positioned with care and connected by heavy-duty tow lines. Their role is not brute force alone, but balance and control. One tractor applies steady forward pull, while the second stabilizes the crane's trajectory, preventing lateral movement that could send the machine sliding into the ditch. Communication between operators is constant, measured in hand signals and engine response rather than words. As torque builds and tires bite into the ground, the mud releases its grip inch by inch. The crane slowly straightens, its weight redistributing as solid footing is regained. This is a reminder that agricultural recovery is as much about judgment as it is about horsepower. A single mistake, too much throttle, the wrong angle, could turn recovery into disaster. In the end, teamwork prevails. The crane is brought back onto stable ground, damage avoided, and work can continue. It is a quiet but powerful demonstration of rural problem-solving, where experience, mechanical sympathy, and cooperation make the difference between loss and success. The Shaktiman 4x4 off-road vehicle is built with one clear purpose: to keep moving when conditions say it shouldn't. Designed for harsh terrain, this machine combines a rugged drivetrain with a compact, utilitarian layout that prioritizes traction, balance, and reliability over comfort. Its four-wheel drive system delivers consistent torque to all corners, allowing it to crawl through deep mud, loose soil, rocky paths, and steep inclines with confidence. Short overhangs and a high ground clearance reduce the risk of getting hung up, while the simple mechanical design makes field repairs practical and fast. In agricultural, forestry, and remote area operations, the Shaktiman proves its value where paved roads disappear. Every bounce, every wheel slip, and every correction tells the same story. This vehicle is not about speed or style, but about endurance, control, and getting the job done when access is difficult and failure is not an option. The road through Taysan Quarry is not a road in the conventional sense. It is a constantly changing track carved by heavy machinery, weather, and relentless use. Every meter tells a story of pressure and punishment, where gravel shifts under weight and mud waits to trap anything that hesitates. This is an environment that demands respect, precision, and experience. As vehicles enter the quarry road, traction becomes the first challenge. The surface is uneven, scattered with loose stone, sharp rock edges, and deep ruts formed by loaded trucks climbing and descending day after day. In wet conditions, water mixes with fine dust to create slick mud, turning gentle slopes into technical obstacles. Drivers must read the ground carefully, choosing lines that balance grip and stability while avoiding soft edges that can collapse without warning. Heavy trucks and off-road vehicles move slowly here, engines working hard at low speed. Torque matters more than horsepower. Tires claw for grip, suspension flexes, and every correction at the wheel counts. A moment of overconfidence can result in wheel spin, loss of momentum, or worse, sliding toward unstable shoulders that drop away into the quarry below. What makes the Taysan Quarry track especially demanding is its unpredictability. Conditions can change within hours. A dry, manageable route in the morning can become treacherous by afternoon after rain or increased traffic. Drivers rely on experience, communication, and constant awareness to keep machines moving safely. This road is not about speed or comfort. It is about control, judgment, and mechanical sympathy. Each successful pass is a small victory over terrain that never truly rests. In Tisang Quarry, the track decides who moves forward and who stops. The 4x4 Schachtermann off-road tracking sequence is a raw demonstration of what truly matters when pavement disappears and conditions turn hostile. This is not a staged test on a controlled course. It is real terrain, shaped by rain, heavy use, and unforgiving ground. From the first rotation of the tires, it becomes clear that progress here is earned, not given. The track is narrow and uneven, bordered by loose rock and deep mud. Ruts carved by heavier vehicles pull at the wheels, constantly trying to drag the Schachtermann offline. In these conditions, momentum must be managed carefully. Too much throttle breaks traction instantly. Too little allows the vehicle to sink. The driver works the controls with patience, letting the drivetrain do its job while reading the surface meter by meter. The Schachtermann's four-wheel drive system proves its value quickly. Torque is delivered steadily to all four wheels, allowing the vehicle to crawl forward even when individual tires lose grip. Suspension articulation keeps the chassis balanced as wheels rise and fall independently over rocks and washouts. Ground clearance prevents the underbody from plowing into mud, while short overhangs help the vehicle crest uneven transitions without getting hung up. As the track worsens, water-filled sections appear. Mud thickens, clinging to the tires and robbing them of bite. Tire smoke briefly rises as rubber struggles against slick ground, a visible sign of how demanding the surface has become. Instead of forcing the issue, the driver corrects, eases off, and finds a cleaner line. Progress is slow but controlled, a hallmark of proper off-road technique. What stands out most is the Schachtermann's mechanical simplicity. There are no complex electronic aids masking driver input. Every response is direct. When the wheels slip, the feedback is immediate. This honesty between machine and operator builds confidence, especially in remote areas where reliability matters more than comfort. Climbing out of the worst sections, the vehicle leaves behind deep tracks, evidence of both the struggle and the success. Each obstacle cleared reinforces the same lesson. Off-road capability is not defined by speed or appearance, but by balance, traction, and restraint. By the end of the run, the Shaktiman emerges dirty, scarred, and still moving forward. That is the real measure of off-road performance. In terrain like this, survival is victory. The 4x4 Shaktiman does not conquer the track. It negotiates with it, inch by inch, proving that determination, good engineering, and disciplined driving can carry a vehicle through conditions designed to stop it. At the 2015 Comus Agricole of Goudelin, the fields of Brittany did more than host a rural fair. They became a living stage where agricultural history was set back into motion. Long before satellite guidance, enclosed cabs, or computerized harvesters, farming followed the rhythm of seasons, machines, and human cooperation. This gathering did not simply display old equipment. It allowed those machines to work again, exactly as they once did. The atmosphere is defined first by sound. Deep, uneven engine notes roll across the field, punctuated by the slap of belts and the steady clatter of metal on metal. Among the most striking sights is a vintage Massey Ferguson combine harvester, an early example of mechanized harvesting that once revolutionized grain production. Its tall profile and exposed mechanism stand in sharp contrast to modern combines. Yet as it moves forward, cutting and processing grain in one continuous operation, its importance becomes immediately clear. This machine represents the turning point between manual harvest and large-scale mechanization. Nearby, a classic threshing machine, machine a batter, anchors one of the most evocative demonstrations of the day. Hand-tied sheaves are fed carefully into the machine, where rotating drums separate grain from straw with deliberate force. As straw pours out in thick, golden streams and clean grain collects below, the scene recreates a moment that once defined the end of every growing season. This is not performance. It is a precise reenactment of how communities secured their food, one bundle at a time. Adding to this historical sequence, a grain winnowing machine, machine a vanner, comes into action. After threshing, grain is poured in, and airflow combined with vibration removes chaff and impurities. Dust rises briefly in the sunlight, and what remains is clean, usable grain. It is a small step in the process, yet one that underscores how much knowledge and mechanical ingenuity existed long before modern processing plants. In the adjacent field, soil turns slowly beneath steel. A Ferguson TE20 tractor, modest in size but legendary in impact, pulls a traditional plow through the earth. Designed to bring affordable mechanization to small farms, the TE20 changed post-war agriculture across Europe. Here, its narrow front wheels track straight lines as fresh furrows roll over, dark and even. There are no electronic corrections, only the driver's hands, eyes, and experience guiding each pass. The plowing demonstration, labor à l'ancienne, draws steady attention. Each furrow is a reminder that good farming once depended on reading the land. soil texture, moisture, resistance. The tractor moves at a measured pace, proving that precision existed long before automation. What truly binds these moments together is the human presence. Many operators learned these skills from parents or grandparents. Others restored the machines out of respect for the ingenuity they represent. Conversations flow easily between generations, sharing stories of harvest seasons, breakdowns, and long days that shaped rural life. By late afternoon, the results are visible everywhere. Grain lies sorted, straw stacked, and fields neatly worked. Nothing feels rushed. The demonstrations unfold with patience, honoring methods that fed communities for centuries. As engines finally fall silent, the significance of the day becomes clear. With the Massey Ferguson combine, the threshing and winnowing machines, and the Ferguson TE20 plowing steadily onward, Gudelin does more than remember the past. It brings it fully back to life. This is agricultural history, not preserved behind ropes, but lived, heard, and felt, proving that the old ways still carry enduring power and meaning. In this head-to-head pull, a Fendt tractor lines up against the legendary Kiravet's K700, a machine known for brute strength and sheer mass. The contrast is immediate. The K700 relies on weight, articulated steering, and raw torque from its massive drivetrain, while the Fendt brings modern engineering, efficient power delivery, and precise traction control. As the pull begins, both machines dig in, tires biting hard into the soil. The K700 leans on its weight advantage, but the Fendt counters with controlled power and balance. This contest is less about horsepower numbers and more about grip, gearing, and how effectively each tractor converts engine output into usable pull. The Fendt 936 Vario MB Track 3 axle conversion is an extreme fusion of modern efficiency and heavy-duty heritage. Producing up to 1,000 horsepower, this unique machine combines Fendt's advanced Vario driveline with a custom 3-axle MB Track-style chassis. The result is exceptional traction, stability, and load distribution for heavy pulling and off-road work. Built for spectacle and strength, it represents engineering pushed far beyond conventional agricultural limits. At first glance, it seems like an unfair contest. Tractors on one side, people on the other. Steel, horsepower, and torque versus nothing but human muscle and determination. Yet as the rope tightens and the signal is given, something remarkable happens. Dozens of people lean back in unison, boots digging into the ground, every ounce of effort focused in the same direction. This tug of war is not really about defeating the machines. It is about coordination, timing, and collective energy. When individuals move together, their combined force becomes surprisingly powerful. Laughter mixes with strain, and the crowd quickly realizes that teamwork can narrow even the widest gaps between man and machine. The tractors may ultimately win on paper, but the real victory belongs to cooperation. It is a vivid reminder that human strength multiplies when people work as one. Proof that unity can generate an energy no engine can truly replace. The Fendt 939 and Claas Zerion 3800 face off in a battle of power and traction. Advanced drivetrains, massive torque, and intelligent all-wheel drive define this showdown. The MB-Track 1500 and the Fendt 516 represent two very different philosophies of tractor engineering, separated by decades of technological evolution. The MB-Track 1500, developed by Mercedes-Benz, is a heavy, purpose-built workhorse. With its centrally mounted cab, equal-sized wheels, and robust mechanical drivetrain, it was designed for maximum traction, stability, and durability in forestry, heavy tillage, and transport work. Power delivery is raw and direct, favoring torque and reliability over refinement. The Fendt 516, by contrast, embodies modern agricultural engineering. Compact, efficient, and highly automated, it features a continuously variable vario transmission, advanced engine management, and precision farming technology. Power is applied smoothly, optimizing fuel efficiency and operator comfort while adapting instantly to changing loads. When these two machines face off, it is less a competition than a comparison of eras. The MB-Track 1500 showcases brute strength and mechanical simplicity, while the Fendt 516 demonstrates how intelligence, efficiency, and control define modern tractor performance. The Curtiss-Wright R3350-32-way is one of the most iconic large radial aircraft engines ever built, representing the peak of piston engine aviation before the jet age took over. This 18-cylinder twin-roll radial, known in German as a stern motor, was developed during World War II and refined in the post-war years for long-range, high-power applications. With a displacement of nearly 55 liters, the R3350-32-WA was capable of producing well over 3,000 horsepower, thanks in part to its advanced turbo supercharging system and water alcohol injection. These technologies allowed the engine to maintain power at altitude and deliver short bursts of extreme output during takeoff or combat conditions. The sound alone, deep, rhythmic, and mechanical, became a signature of American heavy aircraft. This engine is most famously associated with the Boeing B-29 Superfortress, where reliability and sustained power were mission-critical. Later variants powered civilian airliners and military aircraft, proving the design's adaptability and longevity. However, the R3350 also demanded respect. Complex cooling, high operating temperatures, and intricate maintenance made it a true engineer's engine. Today, seeing an R3350-32 were running is a rare privilege, a living reminder of an era when engineering ambition was measured in cylinders, displacement, and raw mechanical power. Imagine discovering a forgotten 45.8-liter BMW V12 in a scrapyard. Most people would walk away. Instead, it was reborn. Displacement stretched to 47,000 cubic centimeters. Power pushed to 750 horsepower. And the engine was mounted on a 1907 American La France fire truck chassis. The result is Brutus, a 2.5-ton chain-driven monster capable of nearly 200 kilometers per hour. This cold start is not just noise and smoke. It is mechanical defiance, a brutal celebration of excess, ingenuity, and raw, unfiltered engineering madness.